In this example, we're finding the derivative f prime of a using a limit. So we'll start with the generic definition f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a all over h. So now we will go to the original function and replace the x with a plus h minus, replace x with a all over h. And notice at this point we have h in the denominator, and we can't simply plug in 0. We cannot evaluate the limit here because you get division by 0. In a situation like this, we need to rationalize the numerator. So we do that by multiplying by the conjugate of the numerator over itself. So remember, the conjugate, we're going to change that second radical to be positive. And we'll just do that in the numerator and in the denominator. So now looking at the numerator, we have the first square root times the first square root. That's going to cancel the radical, leaving us with just the radicand. And then the middle two will cancel each other because you have a minus and a positive. And then we'll look at the last two radicals. Again, that's going to eliminate the radical, leaving us with negative 1 minus 2a all over h times the square root of 1 minus 2 times a plus h plus the square root of 1 minus 2a. From here we can simplify a little bit. In the numerator we'll get negative 2h and in the denominator I'm going to distribute the radical there. We have negative 2a minus 2h plus square root 1 minus 2a. Notice at this point we can cancel the h in the top and the bottom. From here we can evaluate the limit, making that h in the denominator go away to 0. So we have negative 2 over the square root of 1 minus 2a, the square root of 1 minus 2a. Simplifying that, we get negative 2 over 2 square root of 1 minus 2a, or negative 1 over the square root of 1 minus 2a. And this is the derivative evaluated at a.